All right, folks, welcome back. Today, we are going to be learning about terms, and specifically, we're going to be learning about something called like terms. So I want to start here by talking to you about a term and what it is. So we need a definition here. We need to understand what it is we're going to be dealing with. Now, here's what you need to know. A term is a mathematical expression with two parts. So every term that we look at is going to contain two parts. The first part is a number part. So every term is going to have a number part. The second part is going to be a variable part. So when we look at terms in math, we will always be able to identify these two things. The term will have a number part. The term will have a variable part. And then this next part is really, really important. That number part of the term and that variable part of the term will always be multiplied together. So when we talk about a term in math, it's a mathematical expression with two parts. There will be a number part times a variable part. The two parts of that term will always be multiplied together. Now, the number part of that term can be any number you can think of. So it could be 1, it could be -5, it could be 1/2, it could be 12.7. So any number you think of can be the number part of the term. The variable, and before I leave that, let me say this. That number part of the term has a name. That number part of the term is called the coefficient. So that number part of the term is called its coefficient. Now, the variable part of the term we need to talk about as well. You all know what variables are. The variable part of a term can have more than one variable. Can have more than one variable. In the variable part of the term, the variables can have exponents. So that variable part may be made up of more than one variable, and those variables can have exponents on them. And we are going to call this the last name of the term. So the variable part we're going to refer to as being the last name of that term. So every term is going to be made up of two parts, a number part and a variable part. And those two parts have to be multiplied together. So it has to be a number times a variable part. That number is called the coefficient of the term. In the variable part, we can have more than one variable. The variables can have exponents, and we are going to refer to that as being the last name of the term. All right, so let me give you some examples here. Let's use this definition to give you some examples of terms. All right, so for my number part, I can pick any number that I want. So I'm going to go ahead and pick a -5. Now that number part has to be multiplied times a variable part. For the variable part, I can use one or more variables. So I'm just going to go ahead and pick the variable y. So if I have -5 times y, that would be a term. Now, real quickly here, one of the things we want to do in algebra is get used to writing things with the smallest number of symbols possible. So you all are aware of the fact that this dot here is not really necessary for showing that I'm multiplying. If I want to do -5 times y, I can just write them beside each other. Now I want you to listen very carefully here. This way of writing this term, writing it as -5y, would be preferred. So instead of seeing -5 times y with the dot, I want you to just write -5y. -5y is a term because it is a number part, -5, times a variable part, y. -5 times y, number part times variable part. So on this term, the coefficient would be -5. Okay, and then the variable part, or the last name as we're going to refer to it, would be y. So there are the two parts, the coefficient, which is -5, and the last name, y, which is the variable part. Okay, let's make another one. Let's, for our next term, we need a number part. So let's choose 0.5. And then I want to multiply that times a variable part. Now this time I think I'll use the variable x. And I'm going to raise him to the second power. So this would be another example of a term, because I have this number part, 0.5, being multiplied by this variable part, x to the second power. Now again, I would prefer that we write that without the dot and just put them beside each other. So 0.5x squared. 0.5x squared. So this would be another term. In that term, the coefficient, or the number part, would be 0.5, and the variable part, or the last name, would be x to the second power. So I want you to notice that the last name, I want you to notice that the last name includes the variable and the exponent that's on the variable. So that's included. So to form terms, all we have to do is take a number part and multiply it by a variable part. Let's do one more like that. So to make another term, let's pick a number. I'm going to pick 126. Don't ask me why, but 126. And I'm going to multiply that by a variable part. Now remember what I said, your variable part can have more than one variable in it. And those variables are allowed to have exponents. So this time I'm going to do x, y to the second power, z to the third power, just to make this a little fancier. So notice my variable part is a little more complicated this time. It has an x, it has a y to the second power, it has a z to the third power. And again, I would prefer that we write that without the dot. So we'll just write 126 right beside x, y to the second, z to the third. So this is my term. It has a variable, or it has a number part and then a variable part. In this term that I've written here, my coefficient, or the number part, would be the 126, and the variable part, or the last name, would be x, y to the second, z to the third. So notice, the last name, the variable part, contains all of the variables along with their exponents. So -5y, number part times variable part, 0.5x squared, number part times variable part. 126 xy to the second z to the third, number part times variable part. These are all examples of terms. They all have to have those two elements. Now, I'm going to come over here onto a new slide, and I'm going to write some terms. And what I want you to do is see if you can identify the coefficient and the last name for these terms. All right, so let's say I have 14xy squared. 14xy squared. Now that is a term because it has a number part that I can see times a variable part that I can see. And how do I know I'm multiplying? Well, I know I'm multiplying because all of this is side by side by side. That's how I know that's multiplying. So, what do you think the coefficient is? Remember, the coefficient is the number part. All right, hopefully there at home you're answering that that coefficient, that number part is 14. Now, what is the variable part for this term, which would also be referred to as his last name? What would that be? Hopefully at home you're answering xy raised to the second power. All right, take a look at this term. In this term, we have a number part times a variable part. So when you look at this term, what do you think his coefficient is? What do you think his number part is? Hopefully you're answering -3. Now, same term. What do you think his variable part is? What do you think his last name is? Last name is AB. So we're multiplying -3 times AB in order to get this term. All right, now, I want you to look at this one. When you look at this term, you may be sitting here thinking, wait a minute, that's missing something. You may be thinking that's missing the number part, because when you look at the front of the problem, you don't see a number sitting there like you did up here. We saw that 14 very clearly. When we looked at this term, we saw that -3 very clearly. When we get to this term, we don't see the number part. Now here's what I need you to understand. Even though we don't see the number part, he is still there. When you cannot see the number part of the term, there is a 1 there, and that 1 is invisible. Now why is it invisible? I want you to think for just a moment. What happens when we multiply 1 times something? What happens when we do 1 times 5? Or 1 times 10? Or 1 times 256? Well, what we know is that 1 times 5 is 5, that 1 times 10 is 10, that 1 times 256 is 256. So if we multiply 1 times something, it doesn't change it. So if I do 1 times xy to the 4th, it's just going to be xy to the 4th. It's not going to change it. So that's why that 1 is invisible, because multiplying by things by 1 doesn't change them. So when I see this term and I ask the question, what is the coefficient? I need to recognize that just because I can't see it, doesn't mean that it isn't there. It's there. It's just an invisible 1. And it's invisible because multiplying by 1 doesn't change things. So I wouldn't need to write that down. Now, what would the last name or variable part be for this particular term? And the answer is it would be x, y to the 4th power. So notice that when I take that last name, I take all of the variables, all of them, along with any exponents or powers that they might have. So if you ever find yourself in a position where you are missing the coefficient, it's not a big deal. It's not a big deal at all. That just means that that coefficient is an invisible 1. Now, here is another term. When you look at this one, you may say, hey, wait a minute, that's missing a part as well. This time it's the variable part that's missing. That is okay as well. When you see a number like 8 and that variable part appears to be missing, here's what you will say. You will say that the coefficient is 8. The number part of that term is 8. And then when it gets to the last name, or the variable part, what we will say is there is none. There is none. So it is possible for a term to be missing that last name and to have the coefficient only. So every term is made up of two parts. A number part, called the coefficient, a variable part, called the last name. And in that last name, you can have multiple variables with exponents on them, and those are part of the last name. If you happen to be missing your coefficient, then that coefficient is 1, and if you happen to be missing the variable part, then that just means that that particular term doesn't have a last name. Now, here's what we're going to do with this today. We're going to be working on this a little bit all week. Today, what you are going to do is use the vocabulary that we've just talked about to begin to work with like terms. Now, here's what you need to know. Like terms are terms that have exactly the same last name. So I want you to look at what this says. Like terms are terms that are going to have exactly the same last name. So their last names have to be identical. And remember here that the last name is the variable part. So the variable parts have to be identical. So one of the things I want to point out here is that when you are looking for like terms, the coefficients will not matter. We don't care about the number part when we're identifying like terms. What we care about is that last name. So, let me give you some examples. All right, let's say I have a term of 5x. And then I want to have another term over here that's a like term for that. Well, what is the last name for 5x? The last name is x. So if I wanted to make up a like term for that, I would have to use a different number, like -3, but have the same last name. So 5x and -3x would be like terms because they have exactly the same last name. They both have a last name of x. All right, let's say I have 4x squared y. And I want to have a like term over here for that. Well, take a look at that term. What is his last name? His last name is all of the variable parts. So the last name is x squared y. So if I wanted to make up a like term for that, I would have to use a different number, like 5, and then have the same last name. So I would want to have x squared y, just like he does. So notice, exactly the same last name. Let's say that I have AB to the 4th power. What would the coefficient be for that? What would the number part be? It'd be an invisible 1 sitting right there, so we have 1AB to the 4th. His last name, though, notice, is AB to the 4th. So if I wanted to come over here and give you a like term for that, I could choose a different coefficient, like 1/2. But then I would have to use the same variable part. So I would have to have AB to the 4th. So when we say that these like terms have to have exactly the same last name, we mean they have to be a perfect match. The same variables, and those variables have to be raised to the same power. So if the x is to the 2nd power over here, he's got to be to the 2nd power over here. The last names have to be a perfect match. So if I were to say to you, r 3x and negative 5x squared like terms. Are 3x and negative 5x squared like terms? What I would need to do is look at the last names to make that decision. So for 3x, I have a coefficient of 3, and I have a last name of x. For negative 5x squared, I have a coefficient of negative 5, and I have a last name of x squared. Now I want you to notice, those are the same variable, they're both x, but this x is not raised to a power. This x is raised to the 2nd power. That makes them different. They are not a perfect match. X and x to the 2nd power are not the same thing. So the answer would be no. And it's no because these are not the same last name. So this would be a no, not like terms. They are not exactly the same last name. So they have to be a perfect match. It's not enough just to have the same letter. Those variables have to be raised to the same powers as well. But notice again, like terms, same last name. Coefficients don't matter. So I'm going to go through a few of these here and ask this question, are they like terms? And I'm going to pause and give you time to look at it and think, and I want you to answer at home to yourselves before I answer it out loud. So let's say we have negative 3xy squared and 4xy squared. Are those two terms like terms? Negative 3xy squared and 4xy squared. All right, let's see. Last name over here is xy squared. The y is raised to the 2nd power. Last name over here, on the second one, is xy squared. So each one has x, each one has y squared. Xy squared, xy squared. Those are identical, so you should say yes, those are like terms. Let's look at these two. Would x squared y and negative 8xy squared be like terms? All right, to decide, let's look at the last names. Let's look at the variable part. So over here, the variable part is x squared y. What's the coefficient? It'll be a 1, right? So 1x squared y. Over here, what is your last name? What is your variable part? And the answer is, it is xy squared. So what do you think? Are those like terms? X squared y, xy squared. The same letters, definitely, right? Both have x, both have y. But notice the x is to the 2nd power here, and y is to the 2nd power here. So the exponents are on different letters, so this would be a no. It has to be identical. X squared y, xy squared, not the same. What about these two? Negative 6 and 14. Negative 6 and 14. Notice what both of these are missing. This guy's last name, there is none. This guy's last name, there is none. So notice, these two have in common the fact that they have no last name. So that makes them alike. They are alike in that they have no last name. So that would be a yes. Those are alike terms. Let's say we have 8ab and negative 3ab squared. Would those be like terms? Last name here is AB. Well, it'd be nice if I could see him. Let me write him up here. Negative 3ab squared. That's better. Would those be like terms? You have AB, AB squared. Not a perfect match, right? So this would be a no. So hopefully that's making sense. The last names are what determine if you have like terms or not. So let's kind of recap what we've learned here. Terms, made up of two parts. You have to have a number part multiplied by a variable part. Always has to be multiplied. Number part times variable part makes a term. Number part is called the coefficient. When you get to the variable part, you can have more than one variable. The variables can have exponents, and those exponents are a part of the last name. And we're going to refer to that as being the last name of your term. So we gave some examples. Coefficient is the number part, last name is the variable part. And like terms are terms that have exactly the same last name. So when you're looking at terms and you're trying to identify whether they're like terms or not, only look at the variable part and make sure it matches perfectly, like an x with an x, or an x squared y with an x squared y, or an ab to the fourth with an ab to the fourth. So notice, not only do those letters have to match, but the exponents that are on the letters have to match. So in this one, 3x, negative 5x squared, not like terms because x and x squared are not a perfect match. And then we saw the same kinds of things going over here. xy squared, that would be a yes. X squared y with xy squared would be a no, because these exponents are on different letters in those last names. These would be like terms because they both lack a last name that makes them alike. And then AB and AB squared, not like terms because this B is not squared, this one is. We've got to have exactly the same elements. Now, before I leave you to do your assignment, I want to show you what today's assignment is going to look like. I want to kind of explain to you what you're going to be doing with it. So let me real quickly close out of this and then get over here to the computer. When you open up today's assignment, this is what it's going to look like. It is a Google Slides assignment. And these are the directions. It says on the next slide, identify the like terms by coloring the rectangles using the same color. So had we been in class where we could have done this on paper, I would have given you this and some markers or crayons and had you color them. We're going to have to do this a little differently, obviously. It says you will color the rectangles by clicking and dragging the colored rectangles into the boxes in the grid. Make sure all like terms are the same color. So, which terms are like terms? Identify the like terms by coloring its rectangles using the same color. You'll notice over here I've made you a bunch of different colored rectangles. So what I would do is I would start up here with this very first term, negative 3x squared. He has a coefficient of negative 3. That is his number part. And he has a last name of x squared. So I'm just going to start with green, and I'm just going to grab that green rectangle and put it around negative 3x squared. Now, anybody who is a like term for him is going to have the same last name. So that means the last name needs to be x squared and x squared only. That is the only thing that will match is x squared. So x squared y in this box will not work because he's got that extra y and I don't want that. All I want is an x squared. That is his like term. So I will go through each of these terms until I see another x squared. Now right here I see one. Notice it is negative x squared, so what would the number part of this be? The number part would be negative 1, because that 1 is invisible in front of him. But notice he has the exact same variable part of x squared, so I would grab another green rectangle and put it around him. In this next column, I don't see any x squareds. In this next column, right here, I see 10x squared. He has a coefficient of 10. His last name is x squared, so I'll grab me another green rectangle. Next column, x squared over 3. That, by the way, would be the same thing as 1/3 x squared. 1/3 x squared, but he has the right last name. This guy is close. He has x squared, but he also has that y, so that disqualifies him. Next column, I don't see any. Right here, x squared, his number part would be a 1. Whoops, so 1x squared, so I'm going to grab a green rectangle for him. And that looks like all of them. So all of the ones that I have here with green boxes around them would be like terms because the variable part for all of them is the same. It's x squared. So now what you would do is go to your next term. So like we could come right here. We have negative 10x squared y. Negative 10 would be the coefficient. X squared y would be our variable part, our last name. So start with a new color. And then you will go through and use that same color around everybody who is a like term for this guy. Everybody who has the same last name. So that's what you're going to be working on today, and that's how you will interact with today's assignment to get that done. Okay? If you have any questions or if anything about this lesson did not make sense, then please contact me and let me know. I look forward to getting your assignments and grading these. You will not need to show work for this one, so no need to send pictures. Just send me this completed chart. Thanks so much.